Condition monitoring is a generalized method of establishing a machine's health using measured parameters which reflect changes in the machine's mechanical state. The motivation for introducing condition monitoring is to increase the overall safety level in order to reduce the risk of loss of life and property. Today, it is important for customers to consider the stages of implementing a highly advanced condition monitoring system. CM Plus is a 24/7 online system for continuously condition monitoring, data recording and risk analysis. The system supports a wide range of rotating equipment and structures. In addition to vibration measurements, the system performs dynamic alarm conditions monitoring, provides time and frequency analysis of measured data. The system has many features like band-based vibration level measurements, transient signal detection, run-up, goes-down, periodic and on-alarm signals recording, real-time Fourier analysis and orbit monitoring, trend level prognosis and many other options. The system consists of one or several data acquisition devices and a central data server. Data acquisition client provides direct measurement of all system channels and sends results to the server. Depending on measurement hardware, it supports signals from different kinds of sensors such as accelerometers, velocity probe, proximity and displacement probe, thermocouples, strain gauges, tachometers and general current and voltage sensors. Server provides centralized storage for all measurement data in a database and allows connection of different software clients for data monitoring and system management purposes. Manager is used for system configuration, such as number and type of channels, alarm limits and type of data acquisition hardware. The monitor application provides access to the real-time measurement data and alarms. It displays current machine state and last measured values. Analysis application is used for historical data analysis and in-depth investigation of captured raw signals. CM Plus system can be installed in 3 different modes. Demo mode, when all software installed on a single PC and used for presentations only. Non-large-scale projects, up to 32 data acquisition channels, with one single PC for server and DAC client applications. And large-scale projects, up to 512 channels, that consists of one server PC and one or several processing PC. Operator PC is optional and used mostly for real-time data monitoring. After installation, you can use CM Plus Launcher that shows all installed CM Plus software and used to have an easy access to start applications. Also, it represents connections and communication between CM Plus software in real-time mode. Server application provides centralized storage for all kinds of measurement data and system events received from data acquisition clients. To make or change the system configuration, we have to use Manager application. Manager provides access to most aspects of a system work. It's the main tool to configure the system, such as project, machine and hardware settings, timing and communication, channel settings and many other parameters. DAC client is the main data acquisition application that can work independently from server and communicate with other third-party systems, for example control systems. Monitor application provides access to the real-time measurement data. It displays current machine state and last measured values using graphs, tables, and other graphical indicators, like mimic, narrowband trends, signal waveforms, orbit plot, Fourier analysis with fault frequency markers. Mimic is a part of configuration and it can be created in the Manager Mimic editor. Usually Mimic is a static picture of the object with interactive indicators. One machine can have several different mimics. Another useful application of the mimic is informative picture that can be used by engineers. It can be part of documentation, descriptions, photos, or video of the object. Analysis application provides access to the historical measurement data and alarms stored on the server. It is also intended for advanced record analysis and monitoring. Each record in the records database contains raw vibration signals from the sensors installed. The overview page includes mimic representations for quick redirection to the selected channels. Here you can study alarm history and alarm statistics for each machine and also the machine status history, including color-coded status. There are many advanced and useful analysis methods available on the system, making it possible to convert vibration and other dynamic data to useful information concerning the machine's mechanical condition status and development. Post-analysis options have extended functionality as history trend analysis, record analysis, forecast and alarm, and cross-correlation between different parameters. The trend analysis is used to analyze individual condition parameters history, variations and changes over time, as well as how dynamic behaviors and relationships among groups of parameters act together. Forecast analysis is an important part of any condition monitoring system and used to predict when condition degradation and fault development will require service activities. Cross-correlation is a measure of the similarity of two or more time domain signals. Synchronization is used to connect two or more different types of analysis between each other. For example, synchronization between trend and record analysis can show corresponding cursor position on trend graph and records list to compare it or find a correlation in different behavior. Time and frequency analysis allows inspecting waveform and frequency spectrum of a vibration signal. This is the mostly used in-depth vibration analysis tool and has strong advantages regarding tracing and revealing vibration sources and dominating relations between dynamic excitation sources and measured vibration responses in rotating machinery in general. There are many available advanced FFT windowing and filtering functions, different cursors like total harmonic distortion or sideband, and also fault frequency markers with harmonics. Envelope analysis is the fast Fourier transform frequency spectrum of the modulating signal. It can be used for investigation of machinery where faults have an amplitude modulating effect on the characteristic frequency of the machinery. Examples include faults in gearboxes, turbines, and induction motors. Envelope analysis is also an excellent tool for diagnostics of local faults, like cracks in rolling element bearings. Waterfall analysis option displays a group of record signals as a waterfall graph, which provides an additional time axis to show changes of the spectrum during some time interval. Orbit plots are useful to study and reveal periodic and transient behavior in variations in rotor dynamic systems equipped with proximity probes. DC offset analysis is used to analyze the X and Y probe's relative position and can be used to get information about how the rotor position acts in different running modes, from stops to start and further to running states. The DC offset position is strongly influenced by the static rotor bearing relations and will be changed if this relation is changed. Countable diagram plot represents a system's response spectrum as a function of its oscillation regime. It is used to reveal critical speeds and resonances in rotating machinery in general.